Hello researchers and data scientists. Today we embark on a journey into causation tests. These tools, crucial to scientific research and data analysis, help us decipher the dance of cause and effect. Causation tests are applied to determine if a relationship exists between two variables. They navigate us through the vast landscape of data, making sense of patterns and anomalies. Contrary to common belief, not all relationships between variables indicate causality. This is where causation tests are fundamental. They distinguish genuine cause and effect relationships from mere coincidences. They're the foundation of our understanding of the world, enabling breakthroughs in various fields. Causation tests aren't universal. Different scenarios require different tests. In this video, we'll focus on 4 key causation tests and their strengths and limitations. So, are you ready to delve into the world of causation tests? Are you excited to uncover mechanisms that separate cause and effect? Let's get started. Before we delve into the specifics of causation tests, let's first familiarize ourselves with the broader landscape of research methodologies. They are the strategies that guide our search for knowledge. Within this vast realm, we find causation tests. These tests help us decipher the web of cause and effect. Crucially, they differentiate between correlation and causation, allowing us to draw more accurate conclusions. Different tests work best in different situations, and knowing when to apply each is vital for reliable results. Now, are you ready to dive deeper into the world of causation tests? Our first stop, randomized controlled trials, the gold standard in establishing causality. So buckle up and let's embark on this educational journey together. First on our list are randomized controlled trials, or RCTs. These are the gold standard in scientific research to establish causality. RCTs are esteemed because of their unique design and methodology. The crux of RCTs is randomization. Participants in the trial are randomly assigned to either the experimental or the control group. This random assignment minimizes bias, ensuring that any differences in outcomes between the groups are due to the variable being tested, not underlying group differences. Let's look at an example. Suppose we're testing a new drug for high blood pressure. We recruit subjects with high blood pressure and randomly assign them to 2 groups. The experimental group gets the new drug, while the control group gets a placebo. The key is that neither the subjects nor the researchers know who's getting the drug and who's getting the placebo. This blinding helps to prevent bias. After the trial, we compare the blood pressure levels of the experimental group to those of the control group. If the drug is effective, we'll see a significant reduction in the experimental group's blood pressure. RCTs are not for medical research. They've been used to test educational interventions, social policies, and business strategies. For instance, in the late 20th century, economists used an RCT to test the impact of microcredit, small loans to entrepreneurs in developing countries, on poverty alleviation. The results offered valuable insights into the effectiveness of microcredit as a tool for poverty reduction. In conclusion, the strength of RCTs lies in their ability to eliminate bias and isolate the effects of a single variable. They are a powerful tool for establishing causality and are an invaluable asset in the toolbox of any researcher. Leaving the world of randomized controlled trials, we now venture into a fascinating phenomenon, the placebo effect. This psychological response leads to a patient's perceived improvement in their condition due to their belief in the treatment, even if the treatment is a placebo. The power of belief can sometimes lead to physical changes. In RCTs, the control group is given a placebo to ensure observed changes can be attributed to the new treatment. The placebo effect shows that our mental state and beliefs can influence our physical health. For example, patients receiving a placebo often report reduced pain levels. This doesn't mean the placebo effect can cure diseases. It's about understanding how our mental state can influence our health. A positive doctor-patient relationship can enhance the placebo effect. Conversely, there's the nocebo effect, where negative expectations can lead to worse outcomes. As we transition into the world of Cohort, keep in mind the powerful role our minds play in our health. So buckle up as we continue our journey into the captivating world of research methodologies. Next up, Cohort studies. These are observational studies intended to decode the relationship between cause and effect. Essentially, cohort studies follow a group, a cohort, for a specific period. The purpose is to comprehend how different factors influence the outcomes for the group. In essence, it's like tracking the journey of our cohort, observing the factors that might alter their course. Cohort studies are priceless in situations where experimentation is unethical, like exposing people to harmful pollutants. Yet with cohort studies, we can monitor groups exposed to these pollutants without unethical intervention. A key advantage of cohort studies is studying multiple outcomes. For instance, in studying a cohort of smokers, we might primarily focus on lung cancer, but can also observe other outcomes like heart disease. Another advantage is the ability to calculate incidence rates, giving us a clear view of the relative risk associated with exposure. Real-world examples of cohort studies include the Framingham Heart Study and the Nurses' Health Study. Both have provided crucial insights into various health factors. However, cohort studies aren't without limitations. They require a large sample size and extended follow-up period, which can be demanding. Also, the loss of participants over time can result in bias. Regardless, cohort studies are a potent tool in research, granting us insights into the world of cause and effect. So, the time you come across a headline stating that X causes Y, remember the cohort study that likely led to that conclusion. As we've seen, cohort studies provide us with a robust method for observing how certain factors affect our cohort over time. But what if we need to probe rare conditions or slow-developing ones? Here comes the case control studies. It's like being a detective solving a mystery. Cases are individuals with a specific condition. Controls are those without it. Researchers then compare the two groups' past experiences. This tool is especially helpful with scarce conditions' long-term factors. It's economical, effective, and allows examination of multiple factors for one condition. So as we transition from cohort studies, we're gearing up as detectives with case control studies. Let's dive deeper into this intriguing research tool in the next scene. Then we have case control studies, often used in epidemiology. A fundamental aspect of these studies is their observational nature. Effective for examining conditions or factors that are rare or slow to develop. The research process begins by pinpointing individuals with a specific condition, cases, then identifying a similar group without this condition, controls. The researchers then examine past exposure to certain factors in both groups. For instance, they might assess whether the cases were more likely exposed to a specific chemical than the controls. A notable feature of case control studies is that they allow for the examination of multiple factors for a single condition. This is a contrast to other studies that may only focus on a couple of factors. Therefore, case control studies prove useful when addressing complex conditions affected by multiple factors. Consider the mid-20th century research on lung cancer and smoking. Researchers identified individuals with lung cancer, cases, and compared them to a group without lung cancer, controls. They investigated differences in smoking habits between these two groups. The result was a strong association between smoking and lung cancer. Case-control studies are also beneficial when investigating rare diseases. Researchers studying a rare cancer might engage a case-control study to probe potential causes. They'd identify individuals with the rare cancer, cases, and a similar group without the cancer, controls, then compare past exposure to potential risk factors. In epidemiology, case control studies are somewhat like detective work. Researchers, like detectives, are solving a mystery. What caused the condition? Gathering potential factors and comparing exposure to these factors from the cases and controls. Just as detectives compare clues from different crime scenes, researchers compare data from different cases. It's essential to acknowledge that case control studies have limitations. For example, they rely on people's ability to recall past exposures accurately, which can be unreliable. Despite these limitations, case control studies are a valuable research tool. They provide a cost-effective and efficient way to investigate potential causes of conditions and outcomes. The key to a successful case control study lies in careful planning, meticulous data collection, and thoughtful interpretation of the results. In our journey through different research methodologies, we've seen the detective-like prowess of case control studies and are about to witness the snapshot-like precision of cross-sectional studies. Each method has unique strengths and weaknesses. Case control studies delve into the past to uncover connections between factors and outcomes, especially useful for investigating rare conditions. However, they rely on accurate recall and can be biased. Cross-sectional studies, on the other hand, provide a snapshot of a population at a single point in time. They are efficient, cost-effective, and excellent for determining the prevalence of a condition. They can't establish causality, though, and only show correlations. These methodologies, while distinct, complement each other. One identifies potential risk factors and correlations. The other gauges the prevalence of these factors. They both play critical roles, offering different perspectives. So let's move forward and delve into the world of cross-sectional studies, our next stop in this journey through research methodologies. Cross-sectional studies are also key. They provide a unique approach to causation analysis. Think of a camera capturing the entire complexity of a population in one shot. This is what a cross-sectional study does. A detailed snapshot of a population at one moment in time. It's less about following the same subjects over time and more about examining different subjects from the same population at the same time. Why choose this method? It's simple and efficient. Cross-sectional studies are quicker and less costly than longitudinal ones. They provide immediate insights without waiting for years. They are excellent for studying the prevalence of a characteristic or behavior within a population. For instance, determining coffee preference in a city, a cross-sectional study would be ideal. A major advantage is their ability to lay a foundation for further research. They identify patterns and correlations for more detailed studies. However, they have limitations. The biggest is their inability to establish causality. They can show correlation, like coffee drinkers being early risers, but can't prove causality. They provide invaluable data for policy making and planning, such as a census. In health research, they diagnose the prevalence of diseases or health behaviors. In business, market research surveys, a type of cross-sectional studies, understand consumer behavior at a specific time. In conclusion, cross-sectional studies are like a snapshot of a population that reveals the current state of affairs. They are a powerful tool. But remember, it's merely a tool in the vast toolbox of scientific research. The art and science of causation analysis lie in knowing which tool to use when and how to interpret the results it provides. In our journey through the myriad of research methodologies, we've learned that each has its unique strengths and limitations. The art of interpretation is crucial. Understanding these methods is not just about knowing when to use them, but interpreting their results. Cross-sectional studies, for instance, offer valuable insights into behaviors or conditions at a specific time. However, they can't establish causality. Randomized controlled trials, while strong in causality tests, are expensive and can be ethically challenging. Cohort studies observe cause and effect relationships but require resources and time. They can also be influenced by dropouts or changes over time. Case control studies are efficient but more prone to bias and confounding. They're not suited for studying rare outcomes or diseases with long latency periods. The art of interpretation is about considering all these factors and making informed judgments. As researchers, we must interpret our findings with caution and integrity. The of research is complex and nuanced, but with the right tools and the right mindset, we can unravel the mysteries it holds. Each causation test offers unique insights, crucial for validating scientific hypotheses. These tests are the bedrock of scientific understanding, guiding us in our quest to unravel the truths of our world. We began with the gold standard of causation tests, the randomized controlled trials. These are valuable tools we use to isolate the effects of a single variable by randomly assigning subjects to different groups. This approach forms the basis of numerous discoveries in fields like medicine and psychology. Next, we explored the realm of cohort studies. These allow us to observe the impact of certain factors over time. By tracking groups over time, we can observe relationships as they develop. This is essential in fields like public health. Then we examined case control studies. These are our tools for identifying potential causes by comparing cases with controls. This method is used extensively in epidemiology. Finally, we discuss cross-sectional studies. These studies give us a snapshot of a population at a specific time, showing us how various factors coexist. This approach is useful when we need a broad overview, such as when assessing the prevalence of a disease. Each of these tests has its strengths and weaknesses. As researchers, our task is to choose the most effective tool for our specific research question. It's akin to being a chef. You need to choose the right ingredients and the right cooking method. But these tests are also for life, aiding us to make sense of the world around us. It helps us see beyond mere correlations to identify the true cause and effect relationships. So whether you're a researcher or a curious mind, these tests can deepen your understanding of our world. Share your experiences in the comments below. Let's engage in a conversation. And if you found this deep dive into causation tests useful, don't forget to like, share, and subscribe. This is your channel for all things science and research. Let's continue our journey of discovery together. Stay curious and keep exploring the world of scientific methodologies. In any scientific endeavor, it's crucial to acknowledge the sources of our knowledge. Our guide is based on scholarly articles, texts, and online resources. They've enriched our perspective on causation tests with practical applications and real-world examples. Next, we'll credit these sources to ensure transparency and provide you resources for further exploration. Let's move on to our credit roll, a tribute to the knowledge we've gathered and shared in this video. For more details on these tests and their applications, check out the links in our description. This comprehensive guide on causation tests was crafted using various scholarly articles, textbooks, and online resources. We began with randomized controlled trials, turning to design and analysis of randomized controlled trials and the beginner's guide to randomized controlled trials for insights. For cohort studies, modern epidemiology was invaluable. Case-control studies, design, conduct, analysis helped us navigate case-control studies. For cross-sectional studies, we referred to epidemiologic research principles and quantitative methods. Online resources like Towards Data Science, Simply Statistics, and Statistical Horizons offered contemporary understanding. We express our gratitude to the researchers and scientists referenced in this video. We urge you to explore resources and deepen your understanding of causation tests. These tools are key for scientific research, shedding light on cause and effect relationships. Thanks for joining us on this exploration, and keep delving into the world of scientific data.